Okay, so to graph y equals 2/3 x, we're going to find the slope. What's the slope? 2/3, not x. X is the x, 2/3 is the slope. Y-intercept, 0, 0. And then we need to find the x-intercept, so I'm going to do that over here on the side. The x-intercept, plug in 0 for for y, sorry. 2/3 x. How am I going to get rid of 2/3 x? What could I do to both sides? Multiply by 3. Some of you might multiply by 3 over 2, and then you have less steps. Either is fine. Multiply by 3. I'm going to get 0 equals 2x. Divide by 2. And I get x equals 0. So 0, 0. So we have 0, 0 for the x-intercept. We also have 0, 0 for the y-intercept. Yes? Because why? Did you know that?
No.
This exact question and you memorized it?
No.
Somebody else wanted to add on to that? Daniel? Sorry.
Because if you already put the point where the intercept is supposed to be, it's already crossed by the x line.
So you're saying, let me take your words and make them a little bit more algebraic. You're saying that the y-intercept, because it's at 0, 0, that's also the x-intercept,
Yeah.
so we knew that. That's fine. If you knew it already, that's fine. This one you didn't know. Right?
No.
Okay. I've memorized every x-intercept for every graph ever. I know them all. I don't know them all, so I would be very impressed. Okay, so the second one, slope is -3. The y-intercept 0, 1.
Oh, I'm dumb.
You're just yelling at the other one. Yeah. So the x-intercept, we're going to plug in 0 for the f of x side. And then we're going to solve it, so we're going to take away 1. And get -3x equals -1. I'm going to divide by -3. And that becomes positive 1/3. So 1/3, 0 is the x-intercept. That 1/3, 0 is kind of hard to graph. I mean, I can do it a little bit. Probably not that accurate though. So I'm going to really use the y-intercept and my slope of -3 over 1 to graph it. So if we were going to have a quiz tomorrow, if the quiz was just those kind of questions. So if you said, I don't think I would pass, what questions can I answer? You can think about it. So we're going to have a small quiz, a little mini quiz tomorrow that has just these graphing questions on it.
How many questions?
I don't know. I'll let you know tomorrow when I make it up. But I know we're having one. Yay! Parent functions! Yay! Okay, so parent functions are like the people that birthed you. Birth.
There's only one person that...
Technically, there's 2 people that went into that process, but yes, only one person birthed you. You're right. No, but I've had 2 of them, so... Here's my babies up on the wall here, and I know they're cute, aren't they? You can tell that, you might not be able to tell from over there, but you can tell when you see my daughter that she is related to me. I said, when you see her, you can tell. You just think I'm cool. No. Just follow my Instagram, and then you can see pictures.
So you're just trying to get a free follow. Follow me on my platform.
Guess what? First of all, if you follow me, I'll follow you back. Second of all, I don't care.
For real? Follow my son calls and I got you.
For real? You don't have your phone on you.
I know, that's what I'm
Like
saying.
you
Let
have
me write it down for you.
Okay. It's just my name. This is Vicky Criswell. If you, so. Or, yeah, you haven't really used it that much, but I do post pictures of my kids because my family that doesn't live here likes to see my kids. And they're cute. What I was saying is I'm the parent. My daughter looks a lot like me. She's not 100% like me, but she's kind of like me. We have things that are similar, okay? And same with my son. My daughter looks a lot like me, but she got my husband's stubbornness, that's for sure. Not me.
I got my hands.
Oh, no. All right.
I got my mom's look. I don't have my mom's smartness. She graduated from a Xavier University, and then she went to college twice after that.
Okay, I already told you you were a smart person. Okay. So here we have different families, and these families would be like like your families, where they all have similar things. But there's also different families out there. We've got 4 different families to look at, and this whole year we're going to learn about lots of different families. And in fact, we are going to do the exact same thing so many times, over and over again, in every single chapter, that you're going to know how to do it by the end of the year. And that has all to do with parent functions. We're going to do this in every single chapter, what we're starting to learn today. So let's learn it the first time, because the second and third and 7th and 9th time, you're going to be like, this is the easiest class ever. Because you've done it so many times.
Wait, so also in chapter 7 because you...
It's also in chapter 7.
Because isn't that the difficult?
That's the hard chapter, yeah. Okay, so we've got a constant family, which a constant family would be when we have the function equals a number, and this is the parent, when the function equals 1. This one we don't really use so much of. We'll graph, but we don't do so much of parent functions with the constant. We're going to talk about domain and range today. If I said domain and range right now, honesty, would you know how to answer, what's the domain of this? Would you know as of today? I'm going to teach it. It's okay if the answer is no. Would you already know? Okay, that's why I did not think a whole lot of you would be like, yeah, I know. This is something that we're going to perfect this year. Yeah. Could you tell me the domain of a quadratic function? Okay. We're going to perfect that today. Let's write a little. Actually, is it? I feel like it's in here somewhere. Maybe it's not. Let's talk about the domain and range right now. We'll just put it up in this little area. Domain, and if it's later in my notes, then we'll skip that part. So the domain is the input part of a function. It's input. It's like the x value that you stick into a table. Okay, so sometimes we'll refer x as being our domain. And then another way you could look at it is because x goes left to right, it's where the graph goes left to right. So I'm going to write left to right. Or horizontal. Horizontal. All of those have to do with the domain of this function. The range is the output. So once I put in a value for x and we multiply it or we add stuff to it, then we get out a number. That's our output. Usually that goes in the y column. Or if it's a function, you can see these functions right here. Instead of y, maybe it's f of x. It means the same thing as y. Y goes up and down. Or you could say vertical. So here is listed 4 different families. We have the constant family. We have what the equation looks like. They called it the rule. We have a graph. And then we have the domain, which would be all real numbers. You're going to have to write the domain and range for a lot of these, and writing the words all real numbers over and over again gets my hand tired. There is a symbol. You don't need to abbreviate. There is a symbol. And the symbol is what Avneet just said, 2 lines that make an R, like that. It's got 2 lines up and down, it's a capital R. That's the symbol that means all real numbers. So you either write the words all real numbers, or you use the symbol. It's up to you.
What's the 2 L's of all, and the R for,
No. There's different sets of numbers. There's the integers, there's the natural numbers and the whole numbers, and they all have this two thing.
Yeah.
It's just like whoever made it up thousands of years ago or whenever it was made up, they decided to write it that way. Okay, so then we have linear, and linear make lines. So this is the parent function. F of x equals just x by itself. The slope is 1, and the y-intercept is 0. And you can see the graph. It goes all the way from the bottom corner to the top corner straight through the graph. What, Martin?
And through the origin.
Goes right through the origin. Every single point on this graph has the same x and y. So if I pick any point and I say this is the x of 2, guess what the y is? Also 2. Like every single point is 3, 3, 4, 4, -9, -9, 132, 132. And then the domain is all real numbers, the range is all real numbers. We'll talk more about that as well. Absolute value. Absolute value is a V shape. Absolute value is a V shape. How can we remember that?
It looks like a V shape.
Because value, V, done. Absolute value, the definition of absolute value is if I have a number line, how far is that number away from 0? So if I'm asking you how far is the number 3 from 0, you would tell me 3. Or if I said how far is -2 from 0, you would tell me 2. It's always a positive answer because we're talking distance. That's what absolute value means. And because of that, that's why both sides go up. All real numbers can go into this absolute value, but only the positives or 0 come out. Daniel. Let me get through some of this first, unless it's an emergency. Let me get through a little bit more of this first. If it's an emergency, you bring your planner up, and I'll sign up. Okay. For this, the range we write as y is greater than or equal to 0, because the y values start at 0, that's the lowest point, and they go above. Then the last is quadratic, and did you do U-shapes in Algebra 1? Parabola. So we're going to do a ton of that in here. Yeah! Oh man! Oh man! So our parabola equation is x squared. The domain, the x's that you can put into the equation are all real numbers, but when you square anything, it turns positive. So it's either 0 or above. Y is greater than or equal to 0. Now we're going to make a table of values for these 3 graphs. And I made this huge because you're probably going to go back and look at it many times. So fill this in with me. First of all, linear. X, we can choose whatever x's we want. The y's have to be equal to, what's the linear equation? And I'm not going to write the plus 0, I'm just going to write x, okay? So now we use our brain. When we make a table, it is very helpful to have different kinds of numbers in the table. What kinds of numbers can we easily plug in for x?
1.
Okay, I'll put 1 in there here. What else? 2. What else? 0, -1, -2. It does not matter if those are the ones you chose. You can really choose any x's, but these are the ones that I'm going to choose because they're the easiest. Now, if I plug in -2 for x, what do I get out for y? 2, -1, 0, 1, 2. They are the same. That is the parent function, and it would go on from there. We just only wrote down 5 of them. Absolute value. This is y equals absolute value of x. What x's could I easily plug in to take the absolute value of? -2,
Negative
1, 0, 1, 2. So those are going to be our parent function values for absolute value. I'm going to plug those in, and when I plug those in, I only get positive. Now quadratic, I gave you more spaces for. Quadratic, I do use -2, -1, 0, 1, 2, but I always use 2 more. Anyone want to guess?
3 and -3.
Yeah, -3 and 3. Now, if you forget, if you don't have the y column memorized, it does not matter because all you have to do is plug in -3 and square it. If you don't memorize it, you just do extra math every single time. What is -3 multiplied by itself -3? 9. What's -2 times -2? 1 times -1. 1. 0 times 0. 1 times 1. 1. 4. 9. So in the past, I know I've had students who freak out because they didn't memorize these. You don't have to memorize them. You can just find them every time. But I have them memorized because it saves me time. Okay. Can I turn the page, or are we still copying? Is anybody still copying? Okay. All right, so here's some pictures, and you're going to look at the graph, and we're going to figure out what function family it belongs to, and maybe perhaps figure out the equation. So when we look at this, which family does this one belong to, Max? Linear? Yep. The linear family, Mr. and Mrs. Linear. Okay. And then we're going to look for some ordered pairs. 0, 0, 1, 1, 2, 2, 3, 3. Anybody want to guess this equation?
Equation is y equals x.
Right. Y equals x. 2, 2, 3, 3. They're equal to each other. All right, next one. Which family does this one belong to? Constant family. And then we have to write an equation for that one, and it says look at scale. Careful. What's the equation for this one?
Y equals
Y equals 2. So for constant, it's always y equals a number, or f of x equals a number. And this one equals 2. What did you say? Yes. For this, yeah, for constant, yes. The ones that go vertical, there's something different. All right, what family is this one?
Quadratic.
Quadratic is what it's called.
Y equals x squared.
Yep. Y equals x squared. And then the last one makes a V. Absolutely correct value.
Y equals fractional value of x.
Yep. So, what family do you think this one belongs to?
Absolute value of x.
What gave it away?
V.
Oh, it wasn't the fact that there's absolute value sitting here?
No.
Either's fine. So this is the family of absolute value. And then this says list the domain and range. So here we go with domain and range. When I look at a graph, I look at, for domain, I look at left to right. So I look at this graph and I'm looking at these arrows. Will this graph ever stop going to the left?
No.
Will it ever stop going to the right?
No.
It never stops, all real. And I'm using the symbol, but you can also write all real numbers. For range, I look from the bottom to the top. We always want to look at the lower numbers first. We want to look at the negative numbers first, or you will get it wrong. So for range, we're going to look at the lowest part of this graph. What is the lowest part that is graphed
1.
on the y-axis? right? It's 1. And then from there, it goes on forever, up, 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 up.
Well, wouldn't it be y is greater than and equal to 1?
Who just said that? Martin? Yeah. It's going to be y is greater than or equal to 1. Because 1 is the lowest amount, and it goes up from there. All right, so this says student practice. I'm going to give you a moment. I want you to identify the function family and attempt to do the domain and range. We will go over it in 1 minute. Quadratic family, U-shape, quadratic family. Then domain is how far to the left and how far to the right. So we look at this, it's going left and right, and it has arrows. Does it ever stop?
No.
So what's the answer? All real numbers. And then range, we're going to look at the lowest point. I'm thinking up and down. I'm not thinking left or right, and some of you were thinking left or right. I could see it on your paper. We're thinking up and down. How low does it go?
0.
Yeah, we're talking about the y value. It goes down to 0. So it's going to be y is greater than or equal to 0. Yeah. So I saw some people had 3 in there, and you're thinking about the x, but the range is y. Okay, there's some vocabulary word bank right here, which we haven't talked about yet. And of course, this was supposed to be printed on the paper with the next side, so it might be a little confusing. But I think I've repeated it enough that you don't have to keep flipping. The main words that you should know after today are going to be translate and reflect. Translate is when you take something and you slide it. You translate it, you slide it. Okay? Translate it and you slide it. Reflection would be like a mirror, except it's going to be up or down or side to side. Reflection. Those are the only ones we're going to cover today. So slide, we're not calling it slide. What are we calling it? Translation or translate. And then flip, we're not calling it flip. We're calling it reflection. So not only are you doing this stuff, but you're also using mature mathematical vocabulary. So, translations. We've got 2 kinds of translations. We have vertical translations and horizontal translations. Vertical would be up and down. Vertical would affect the y. Horizontal is going to be left to right, and it would affect the x. So from geometry, you probably translated some figures where you would slide them. You would move them left and down. Here are some really funny looking notations. These are called function notation of what we're about to do. This is called function notation because it has this f of x in there. What this says is if you take a function and then you add a number to the function. If you take a function, you add a number, it moves the function up. That makes sense? If you take a function and you subtract the number, it moves it down. That's what these say. These are a little bit more confusing. Here is inside of the function, if we take away a number from the x first, before we do the function. If we're doing this inside of the function, so that could be like inside of the x squared, before the squared happens, inside of the absolute value. A lot of times there's parentheses. Inside of the function, if you take away x, a number from x, that's actually going to take it to the right. If you're subtracting a number, it goes right. Do you see how that does not make sense? Can we go over that again? If you subtract a number, it moves the whole thing to the right. If you add a number inside of the function, it moves the entire thing to the left. So what we have to be very careful about is anytime we do a horizontal translation, it's going to be the opposite operation. Opposite operation. If it's inside of the function, it's going to be horizontal, and it's going to be opposite of the sign that is there. So if I do subtract h, it doesn't go to the right, it goes to the left, it goes opposite. If it's outside of the function, it's normal, like up is plus. And it's vertical if it's outside the function. So these are the things you have to memorize because these are the things that will happen in all chapters. Every single chapter, we're going to have things that look like this. They're just going to be different parent functions. So example 2, we have x minus 4. We're going to graph x minus 4 and its parent function. Describe the transformation. So it says graph x minus 4 and its parent function. What is the parent function for x minus 4? Y equals, or f of x equals? You're not answering the right thing. Parent function. For x minus 4, is that a number by itself? Does that have an x? Does it have an absolute value? Or does it have an x squared? It's linear. So the parent function is f of x equals x. So that's what I'm going to answer for my parent function. It's linear. I can write words on here too. Linear. So my parent function is the linear parent function. It wants me to graph the parent function. So the parent function is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. You guys have straight edges? Good. Then don't dot them all. Just finish with the ruler, and then I dash the parent function so you can tell the difference because I'm not using color right now. I'm just dashing it. It's so dashing. So now, for the parent function, to get to x minus 4, what is happening is we have this x, this linear function, and then we are taking away 4. We have a linear function, and we are taking away 4. So we look right up here at this little chart kind of thing. Which one up here has the function, then take away 4?
Down.
The vertical translation down. See how that one has the function, then take away 4. See that one? So to describe the translation, we use the mature vocabulary and we write translate 4 units down. And then you know what you do? You go over to this graph, and every single point that you dotted on this graph, draw a new one 4 units down. Every point, draw a new one 4 units down. Every point, draw a new one 4 units down until you have enough to connect with a straight edge. And then that is our translated figure. Did you guys do this in Algebra 1?
Yeah.
Good, then this should be cake. Red velvet. And we're going to answer the domain and range about the g function, not the original parent function. We're going to answer it about the new one. What is the domain? What x's left to right does this cover? Left to right. Arrows mean all real numbers. All real numbers. Range is how far down to how far up. All real numbers. And looking back at your notes, that's what we wrote the linear would always be. So here's a new one. F of x equals absolute value of x plus 3. And we have to figure out its parent function. What family does this belong to? Absolute value. How did you know that? I don't see a V.
Because you said absolute value.
Mm-hmm. You'd think that would be a hint. What does the parent function look like? F of x equals absolute value of x. That's the parent function. So then we use the parent function points that we graphed, or that we put in that table on the other page, where if I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in 2, I get 2. If I plug in -1, I get 1. If I plug in -2, I get 2. That's coming from this page here.
So what did you do is read up?
Uh-huh.
What did you do is read up?
Oh, this is my parent function right now. I haven't done that one yet.
Oh, okay.
Yeah. And yes, I will. This is just my parent function. So I want you to graph both until you don't ever need to graph the original anymore. But for now, we're all graphing both. So now, will I go 3 up? So we're going to look right here, and we see that this absolute value has a +3 after it. So this is like a function, the parent function, +3. That's what this is saying right here. Parent function +3. The parent function +3. So we go up to the top, and we see f of x plus the number on the outside of that function says we're moving up. So we're going to take each point up 3. Each point up 3. Each point up 3. And that is our new function. I did not describe the transformation. Translate up 3 units.
Oh, sure.
Domain. How far to the left, how far to the right? All real numbers. And again, until you can figure all that out, it does have the domain over here as all real numbers. The range is different though. So we look at this V and we say how far down does this V go to? It only goes to 3. So because it goes to 3,
Y is greater than or equal to 3.
y is greater than or equal to 3 for the range. Yes.
When you're finding the range, do you base it off the parent or
The new one.
Okay.
The new one. Thank you. That's a good question. Make sure, the parent function is there just to help us know what to move up 3. But then we're really answering all the questions about the new one. Okay, graph f of x equals absolute value of x minus 5 and its parent function. What family is this one? Very good. So the parent function is going to be f of x equals absolute value of x. So now, when you look at this x minus 5, do you see how it's inside of the absolute value? Okay, so it's inside the absolute value. That means it's inside of the function. This tells me it's a horizontal transformation. Left to right. So up here, see how the numbers, the plus or minuses, are inside of the parentheses? Those are the horizontal ones. Which one does this look like? This one's minus 5. Is that right or is that left?
Right.
So minus 5 is actually going to move us to the right 5. So we're going to say translate 5 units right. Oh, this got cut off by the copier. Good thing it didn't get cut off all the way. We have enough to graph. So absolute value, the parent function is at that -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. That's where our parent function is. We just graphed it in the one right above it too. I'll move my hand in a moment. I got my parent function. And then we need to move the entire thing to the right 5. So we take each point and we move 1, 2, 3, 4, 5 to the right. Each point, 5 to the right. And then draw your new V shape.
Ah, shoot.
Domain and range are on the next page for that, but that's because it got cut up. I'm just going to put them right here. Domain, range. So domain is left to right. What's domain for absolute value? We just answered the same question right above it. It's all real. Is the bell about to ring? Is it 50 or is it 45? 45 or 40?
40.
So it is about to ring. Range is going to be y is greater than or equal to 0. I got to hand out your book. Okay. So next class, we're going to have a quiz on graphing lines. There are 2 review graphing line questions in here. It's on the second page. Yep. The bell's going to ring in 2 seconds. Oh, you just have to wait. It's a 10-minute class. I talked way long today, I guess. Okay, but I want to show you real fast. On the second page, question. Oh my gosh, what's happening with my computer? On the second page, I gotta turn off the thing. Page, the questions are all just quiz related on that second page. So those are setting for your quiz. Those answers will be posted. The first page, we kind of covered all of that. The back of the first page, we didn't get to example 4 or exercise 4. So if you just want to wait for 4 and 5, if you want to hold up on 4 and 5 and 6 on that page, that would be fine with me. If you get everything done except for 4, 5, and 6, that would be fine.